what we covered in terms of very basic things about Java. And Java is object-oriented programming language, and the most important concept is object and classes. And class define a kind of object. And what does that mean? Okay, so let's go back to the very basic idea. And this is a very basic class. And class can contain data. So this is a very basic class, contains two pieces of data. This is representing a fraction, and the fraction has a denominator and denominator and denominator. So it's an upper part and lower part. So that's very simple. So you all know that class can contain data and method, data and code. This one only have data. So we can use it. How do we use it? We have another class, and which has a main method, and we can create an object of f. The object is a fraction, like this one, and after you create one, you have access to its member, which is the data inside it. So we can see that we want to print it. So we can print f, well, we can say fraction f dot upper and plus f dot lower. So this one will print things out, and take a guess what will print.
A fraction. The slash. Yeah.
Okay, it prints this one, fraction 0 slash 0.
So it's default to 0.
Yeah, so it defaults to 0. Whenever you create something, the Java compiler generates a default constructor which initializes all the variables to 0 and all the pointers to null.
But won't it have like a bright squiggly line under that because you didn't assign it a number or no?
It doesn't. So the default it will be actually, because it's public, and public can be assigned somewhere else, so it doesn't know. Okay, so this one only has data, and of course we can actually add method. Well, for instance, we can actually have a method. So this is public string and toString. So this one is a method which returns a string, and so C fraction. This is pretty much, I want to say the same thing with this, upper and lower. Okay, so this one, toString, is a method of this class. To use this, now I have a toString, I can just pretty much define. So toString. So f dot toString, I can call this toString. Okay. There's a problem with it. The toString, the whole purpose of this thing is return a string. And I constructed a string and return to it. If I call it like this, I basically throw the string away. So I want to get hold of the string. What do I do? You have to have a variable somewhere. Either have this one can be some variable here, the string value, which assigned to that. So when you call toString, the toString method will construct a string and then pass that string reference to this local variable, and then you can just print this. Let's run it, and guess what will print? It will print exactly the same thing. Yes.
Wait, can't you do system.out.println and then in parentheses just do f.toString?
Yes, that's another one. So basically, you can see that this toString, when you return something, it can be assigned to a local variable, or it can be assigned to a instance variable. For instance, there is some other field here. You can assign to that field, or it can be assigned to a parameter. So in this case, I can do this. I can do that. And when you do this, basically, you still assign the return value of this method to a variable. But in this case, the variable is println's parameter. So you understand the concept of that some of the method takes parameters. And those parameters are special variables, special local variables. But the local variable's value is initialized by the caller here. So basically, this one, f2string, construct a string and return it, and the return value got assigned to the parameter of println. So that's how it works. Okay. So now we have this one has a fracture as so basically all the class behave like this. Class is a combination of data and code. Now we have both data and code. Let's do something fancy. So well, we want a constructor. So no, let's go back up a little. So in this case, you can manipulate the fracture from outside. So basically, I can do this: f dot upper equals 3, and f dot lower equals 5. Okay, and then if I run it, what will actually print?
Fraction colon 3 over 5.
Yeah, fraction colon equal to 5. Exactly. So you can see that it basically allows you to manipulate this like that. Well, let's do something fancy. So again, this is a review. You'll remember this thing called constructor. So constructor looks like this. Constructor is a special method which is called when you create this object, and it allows you to give it the parameter, which in this case I define 2 parameters. And now I'm allowed to do that. You know what? We can actually be lazy at this point. So we can just take one object, take one parameter, and then initialize this upper with u and the lower is always 1. So it doesn't have to initialize all of them. You can leave something out. So in this case, I will actually initialize this with 5. And now what it will print? It will print fraction colon 5 over 1. And what if I do that? Now it will, it will print 2 lines. And the first line we already know it's 5 over 1. What's the second line will be like? 5 over 10. So this is tells you that the manipulation of. Understand how it happened?
Is it overriding?
Yes, it's overriding. So this one directly manipulate the fracture. So this one always do that. Okay. And I'm sure you remember that in the lecture sometimes you don't want a class doesn't want other class to manipulate this data directly. So you actually try to put it a private one. And what will happen then?
You can't change it.
So in this case, you see that, I cannot compile this anymore because I don't have access to this one. Okay. To change this, if I really want to change that, I need to ask this class to give me something. So this can give you another one, which is a method that others can call, and it's called setLower and give a value v. And then in this case, lower equals v. Okay, so I don't allow you to change the lower directly, but I gave you a way to change it. So now instead of setting it directly, I call this method set lower and then give it a 10. So that has exactly the same effect as just setting that value to 10. Okay, so I run it again, and what will happen?
The same thing.
Exactly the same thing. So again, this is a review for the very important aspect of what's a class, what's method, and what's an object. Okay, so and what's the benefit of this? Why don't we just allow the other class to manipulate that? Why don't we want to hide it? Well, sometimes there are things you want to do when you trigger. For instance, that the lower value cannot be 0. You want to enforce it here. So this, making it private, make it very easy for you to enforce it. So for if v equals 0, then we say
error
system.error.println, and we're saying that denominator cannot be 0, and then we basically refuse to do anything.
Just return blank.
Okay, so now if I say change it to 0 and I run it again, what will happen this time?
Nothing will appear. Actually, the first line will appear, the second line.
Think about it again.
No, the error thing should appear. And then
nothing else? You're wrong.
5 over 1 is the error thing?
You're wrong again. Okay, let's see.
5/1 again.
So what happened? Okay, let's run it.
Did it call? Oh wait, no, never mind.
Just a second. So what happened? Let's run through. So basically, the first one is easy. You construct a you construct a object like that, and then you print the thing. This one is easy to understand. Let's step into this and see what happened. So if v equal 0, which is true, and then we print error, and then we return. So we're returning from here, and then we still need to print this. You're not terminating the program. So there are ways to terminate the program, but we didn't achieve that. So we exit this thing without just print one on the error message and saying that you can't do that, but we didn't blow up. We didn't terminate the program. We just said that you cannot change it. And
so
then
it prints the original.
Yes, and since it's not changed, so it still prints the original fraction. Okay, got it? Okay, so well, let's do something fancier. Let's do addition. Well, no, I mean multiplication. So multiplication. So we can actually do a multiplication, and so this thing is that it's a fraction which takes another fraction as the parameter. So this thing is we return a fraction, and then we return a fraction, and then we call it multiply, and then we take a fraction. So other. Here we have a fraction return value. We need a new fraction, which is the okay. Let's add another one. So basically, instead of this, I use int lower, and then this will make my life easier. Okay. So you want to have a return value which is a new fraction, and the upper is this dot upper times other dot upper over this dot lower. So this is definition of the multiplication between fractions, right? And the other dot lower. Okay. So what it does, and then we can do a return. What's this one do?
It's return.
Okay. So what will this one do? So basically, this one is this times other equals return value. So this is what this method do. So you can actually simplify this by doing this.
You don't need the second one.
Yeah, you don't need the second one. So they are the same. Okay. So let's see what we can do here. So let's say we need to create two fractures. Let's say 1/5, and then fracture another one. K equals new fracture. Give me a number.
10.
10/5. 5. Okay, cool. And then we say that fraction we do a multiplication. So so f dot multiply k. Okay, and there is a problem. What's the problem? So multiplication is another method which construct a fracture object and then return it. So we need it to equal to something. So m equals this.
Or you could just, no. Or you can print it.
And then I can do m dot to string. Okay. And guess what we'll print?
No, 10 over 20.
It will print 10 over 25. Why? Let's actually stop here. And then so here let's step through. It's very important to understand every single aspect. This seems very simple, but it's a basic building block. You need to understand its very aspect to be able to build on top of it. So you can see that f is 1 over 5. It's
Variable. Just click
okay. Okay, we already have it. Okay. F is 1 over 5. And we can see that K is another object, 10 over 5. Wait.
What?
Yes, 10 over 5. And then remember that the multiplication is basically it constructs another fraction and then return it. So we expect to see another m, which is different from the other two. So here is m. M is upper times upper equals 10, and then 5 times 5 equals 25. So that it will print out. Oops.
Oh no.
What went wrong? Unable to initialize. What went wrong?
Well, it still worked. It just had an error after.
But this.
I think you just pressed continue and then it decided to continue too much.
I guess. Anyway, so this one should print out 10 over 25. Okay, so it's about to get a little bit more confusing and see whether you can actually bear with me. Okay, so how do I get it confusing? Okay, so this one is a multiplication which takes this and that. And I want to be able to create another class. So okay, I wanted to see actually these two methods seems to have very similar code and seems to conduct exactly the same functionality, but there are some subtle differences. The first difference is that this one is static, and this one is not. The second is that this one has this. It's actually referencing this parameter, and this one doesn't need it.
It's 2 parameters.
And how do we use this one? So what's the static? So the purpose of this exercise is to introduce the keyword, review the keyword static. What does static mean? Do you remember? Okay, so all these methods without the static keyword, it has to be called with an object. It's somehow associated with an object. Well, for the exception, maybe this one. This one actually creates an object.
It has something to do with it?
Yeah, so all these called instance object, and that's the difference between a class and an object. A class is a kind of object. A class can have many different objects. And each of these, without the static keyword, is associated with an object. Static method, on the other hand, you will see actually static field in the future, but we won't cover it today. Static method is not associated with any object at all. It's associated with this one. So this multiply and this multiply is very similar, but their usage is a little bit different. How do we use it? So you can see that all this multiply and toString, these two has to be called by an object. So this is f, this is m. They have to be called with a object dot something. But that other multiply, I can do this. And now the other one, and it can do this, fact dot multiply. And the left is f, and the right is k.
It essentially does the same thing, right?
Yes, it does exactly the same thing. And so the printout will be
10 over 25, 10 over
10 over 25, 10 over 25. But bear in mind, the m and ml will be pointing to two distinct objects. They look like the same, but they are not.
You're printing m twice. You have to print m once.
Yes. Well, yeah, that's my problem. Okay, let's see. Still the same. So this, hopefully you understand what static is for. Okay, you can see that there are several methods here. So toString, multiply, and set lower. Well, maybe we didn't use set lower. But anyway, all this non-static method needs to be called using a receiver. What is a receiver? The receiver is f. Here is a receiver to this one. And this one is a receiver to that. Here, the multiply is a static method. It doesn't have any receiver. We just use the class name. Yes, that's a class name. You call it the static one. Okay? And what else? So that's what else? Okay. There is another kind of thing. So basically, usually a class, we said that class is usually a combination of data and code. And there are classes with only data. You should saw that. We construct the class with only data. You can manipulate that. But on the other hand, there are classes with only code. That's possible too. Let's see an example very quickly. So, well, we have existing example here. This is a class with something called nothing else. And to make it clear, I can actually create another one. So, class, and let's copy this thing over. You can see that there's a problem. Why? Because we cannot manipulate, we cannot use this field outside of this directly. So for this example to work, I need to get another two method. So public. So I need to get so for this example to work, they didn't collect enough money.
No, he just got an email that was like,
Okay. Bring your attention back, please. So you can see that this multiply does exactly the same thing with this multiply, right? So this is an example of class with no object, just code. And we can do the same thing, and we just replace this with and we can call it like that. And there are something other weird thing is that sometimes you will see code like this. So all of a sudden this becomes an instance. This is no longer a static method; it becomes an instance method, and we need a receiver to do to call this. And how do I get a receiver?
Will they be equal to
So, well, it doesn't have a constructor, but the Java compiler will actually create a compiler, constructor for it. So, and that's how you call it. And if you run it, it will see exactly the same result. Okay, and so so in summarize, we today we try to reveal the concept of class, method, static method, instance method, constructor, private, public. So basically gist of Java class and basic we reviewed today. And any questions? Okay, so since we have some time left, let's do some other things. So let's do some fun things. For instance, instead of this, we have, so this is no longer a fracture. Wait, so what do? Okay, we create something else. We create a book. And suppose that you are a librarian, and you need to manage a whole bunch of books. And the book will have, well, let's make it all public for now. We will add it. So it will have a call number. So you know that the books in the library all have a call number. And for the simplicity case, and we just use integer. And then we will have, well, all the books will have author. And then we'll have name.
Title.
And then we'll have publisher. And what?
It says title, not title.
Sorry. And then we'll have here. Okay. So suppose we have a list of the books, and then we can. Well, this is another example of class. Its object only has data. It doesn't have any code. We'll add code later. So, and then why? I will just use this. Okay, I can define a public void static void name. And now I have, I want to initialize an array of this book. So basically I have like 5 of those books. It doesn't matter how many, so we'll see. So let's see, book. All books equal. This is basically an array of books. New book.
Hey!
Let's say we have 4 books. Okay. And then 4 made up books. And we can make all books. 0 book. New book. And then all books. 0 dot all. We can see that call number is maybe 0, and then all books. Maybe author is well Adam, and then all books.
Title. Harry Potter. Adam's book.
Well, let's forget about it. We are running out of time.
Year.
It's 1984. Okay, and then we have 4 books, right? We need
I just noticed that on the test it said there's a verb on. Like, what? Like futuristic books. Yeah.
Okay, so this is book 1, and this is book 1. I hate this keyboard. Where is it? Okay, so this cannot be odd item anymore, and this must be E, and this is 2001, and then this one is
3,
3,
2.
2.
Mike. What's his name? What else?
Mike,
Yeah.
and
2008.
2, 9. Okay. Wait, I made a mistake here. And then 3.
Zeke. Zeke.
3 and what?
Zeke.
Z.
Z-K. Z. Okay.
And then it's 36. Okay. What do I want to do? I want you to give me a book with the give me the oldest book of them all.
Zeke. That's the author.
No, I mean programmatically. So you don't know which book is which. You just know actually at this point that you have a whole bunch of books in this library, and I want you to be able to give me the oldest book. How do you do that?
If you pick one and compare it to
Okay.
2.
How do I pick one?
No, you pick okay. If all books 0.year.
Okay, I'll just tell you what's going on. So basically, this is an example of how do you manipulate these things and traverse the book. So you assume you have a book which is oldest. So you book oldest. And you just pointed to it. And remember that each of these variables is a reference. Every variable is a reference, and reference is basically a pointer to a heap object, and the heap object is created using its constructor. So this one is also a reference. It's a pointer points to a heap object. So oldest equals okay, well, I'm just assume that this one is the oldest, and then I will traverse the rest of the books to see whether my assumption is right. If it's not, let's replace it. So basically, we go int I equals. Usually we go I equals 0. I is smaller than all books length. So the array has a length field which tells you how large that is, and then I plus plus. But in this case, since that we already have the first one, you don't need to start with 0. Start with 1. And then we need to find out whether our existing book is oldest or not. So if oldest year is, well, younger than so we only care about if we were wrong, right? When are we wrong? When the year is younger. So oldest it turns out to be younger, so we need to correct our mistake, which means that So we just assume that we know, okay, the oldest book must be the first one. Of course, if this is an empty array, then this line itself will have a problem. So this code doesn't work on empty array. And then you traverse the rest of the book and we compare this year with your on record orders. If you made a mistake, you find an older one, then just replace this one. And you find another even older one, replace this one. So hopefully this one will pick up this. And let's see, system.
Well,
Well, I just need to print out. So the correct result is Zeke, right? Let's see whether our endeavor is correct or not. So we need to. Oh, this also Zeke. We got what we want. Okay, so this is a manipulation of array, and how do you traverse an array? Okay, and I guess we're running out of time, and this is the end of the class today. And hopefully you had a little review of method, return value, class, instance method, and static method, and also private and public fields. And this week, I want you to finish these three first, and we'll review them next week. Okay. Be sure to finish this. And if you did already finish this, you can work on the Hammond, the text part. You don't need to worry about the graphic. The graphic we will work on Android. And also, so be sure to finish this, and then Hammond the text part, and then if you finish all that, you can start working on these. Okay? Okay. Class is dismissed. Thanks.